So we have been talking for the last few lectures about the sampling distribution of the mean. So all this time in chapter 8, we were using X bar as an estimate of mu, and we were applying X bar, right, the sampling distribution of the mean to these application questions that we were doing. So our random variable has been X bar. But what I want you guys to realize is that there's other statistics that exist, not only, the sample mean. We might be interested in a proportion, right? A proportion is another way that we could describe a population or a sample. So the mean, my point is, the mean is not the only measure or statistic, right, that exists. It's not the only way that we could describe our population or a sample. So in section 8.7, we're going to switch gears now and look at the sampling distribution of the proportion. So I'm introducing a new parameter. And you guys know what a proportion is. You've learned about proportions since elementary school. A proportion is just a fraction, a ratio, or a percentage that indicates the part of a whole. So it could be part of a population or a sample that possesses a particular characteristic. So for example, I could be interested in the proportion of students in our class that have brown eyes. I might be interested in the proportion of students in our class that like going to the beach over the summer. I might be interested in the proportion of students in our class that are math majors. So that's different than a mean, right? A mean is a numerical value that describes the center of a distribution. A proportion can be written as a fraction, ratio, or a percentage, and it just gives it's just part of a whole. That's all it is. So we have two proportions. Whether we're describing the proportion of a population, then we would have the population proportion. Or if we were describing a proportion of a sample, we would call it the sample proportion. Just like we have a sample mean and a population mean. So the population proportion, which we'll look at first, is the ratio of the number of observations in the population that possess a particular characteristic to the population size. So we use P to represent population proportion, and it's equal to this ratio, X divided by N, where X is the number of occurrences or observations in the population that possess that particular characteristic, and N is the population size. Now, if we were interested in the proportion of a sample, we call that the sample proportion. And that's still a ratio, but it's the ratio of the number of occurrences or observations in the sample that possess a particular characteristic over the sample size. We can't use the same symbol as the population proportion, so we use P with this little symbol over it. It looks like a triangle without a bottom. We call that a hat, so P hat. And it's equal to the ratio X over N, where X is the number of occurrences in the sample that possess this particular characteristic. But now this time we're dividing by sample size. So let's look at an example. Example 13 says, Professor Smith surveyed a random sample of 420 statistics students. One of the questions was, will you take another mathematics class? The results showed that 252 of the students said yes. What is the sample proportion P hat of students who say they will take another math class? So I'm asking you guys to calculate the proportion of students from this sample that said, yes, I'm going to take another math class. So this is just going to be a ratio or a fraction. It's X over N, where X is the number of students that said yes, right, that possess this particular characteristic, which is, yes, I'm going to take another math class. And then we have to divide by the sample size, which is 420. So let's identify N equals 420. That's my sample size. And X equals 252, right? Because that's how many possess this particular characteristic. So my sample proportion p hat is going to be 252 divided by 420. And let's write that in decimal form and percent form also. So proportions can be written three ways. So this is equal to 0.6, or that's the same as 60%. So we could say that 60% of the students in the sample said, yes, I'm going to take another math class. Example 14 says, a university wants to know the proportion of its students who are satisfied with the new online learning platform. To determine this, a random sample of 500 students was surveyed, and 320 of them reported that they're satisfied with the platform. What is the sample proportion of students that are satisfied with the new online learning platform? So again, I'm asking for a proportion. So really in these two examples, we're just practicing calculating a proportion. It's just a statistic. So we have n equals 500 students that are being surveyed, and X equals 320 of them said they're satisfied with the platform. So what is the sample proportion of students that are satisfied with the new online learning platform? Well, we're going to call that sample proportion p hat, and that's going to be equal to X over N. So the number that said we're satisfied over the sample size. So that's going to be 320 divided by 500. And let's write that as a decimal and as a percent. So as a decimal, it's equal to 0.64, the proportion, or we could write that as 64%. So that's how I want you guys to think of a proportion. A proportion is just part of a whole. It's just a ratio. And we could write it as a fraction, a decimal, or a percentage.